Hi, this video is going to take you through how to use the Pythagorean identity. So the Pythagorean identity is this guy. Now, we call it the Pythagorean identity because it resembles a squared plus b squared equals c squared. And if you watch your homework video, you would know where it comes from. It's an identity because it's a true equation. So if they're telling you to use the identity, automatically, you should write it and use it. Now, you see how it's cosine squared and sine squared? We do not write that because that looks like you're squaring the theta and not squaring the trig function. If you want, you could put parentheses around it and the exponent on the outside. But for now, let's just leave the exponent after the sine and before the theta. From there, you're going to use what they give you. Our goal is to find tangent. We have cosine, and that's kind of it. You know you're in quadrant 2. So all we know is cosine. So what I'm going to do is I'm going to input what cosine is. I do not know sine. And my pen is not really great right now. It's glitching a lot, so bear with me. We have sine squared theta. Now, we have cosine. They're saying cosine is negative 0.7 squared. Right? Cosine is negative 0.7, but we have cosine squared. So you have to square the negative 0.7. And from there, all you have to do is solve. We have sine squared theta plus 0.49 when you square that in the calculator. If you're not getting 0.49, if you get negative, it's because you didn't put parentheses around the negative 0.7. And the exponent should go on the outside of those parentheses. We're going to continue solving for sine by subtracting 0.49 on both sides. And you get sine squared theta equals 0.51. You're going to take the square root, and we're going to get sine, because the radical undoes the exponent. I get sine theta equals plus or minus the square root of 0.51. I'm not putting that in the calculator yet. Even though it says round to the nearest hundredth, you're supposed to save the rounding at the end. If you round too early, you might get an overly rounded answer for which you'll lose 0.4. So the question is, do we have positive sign or do we have negative sign? And what you're going to do is use the next piece of information. They're telling you you are in quadrant 2. So your quadrants go like this. 1, 2, we wait for my pen to work, 3, and 4. And in the second quadrant, we have negative x and positive y. What that means is that we have negative cosine and positive sine theta, right? Because cosine is x and sine is y. So that means we are just going to keep the positive value. We're going to reject the negative, and we have sine theta is equal to positive square root of 0.51. Now that we actually use the identity, what are we going to do with it? So you're going to go to the next part of the problem, which is the actual question. They want you to find tangent. Now, we know a lot of things about tangent. Tangent is opposite over adjacent with SOHCAHTOA. Tangent is sine over cosine. Tangent is y over x. You need to know all three of those things. The thing is, we're not talking about opposite and adjacent in this problem. We're not even really talking about y's and x's. What we are talking about is sine and cosine. So I'm going to go with that one. And we have tangent of theta is equal to sine of theta over cosine theta. That means tangent. Well, sine is the square root of 0.51. And cosine, they gave me in the problem, that was negative 0.7. So that's what you're going to put in the calculator. And if I were you, I would try this now to make sure you can do it on an assessment. We have the square root of 0.51 over negative 0.7. That will give you negative 1.02020406. And they want you to round it. So we are rounding to the nearest hundredth, which means we're going to have negative 1.02. And that's our answer. Let's go on to the next one. This is how you might actually see it as a multiple choice option on the regions. And I understand there are so many different ways to do it. There are even different ways to do the do now one that we just did. But we're going to practice using the Pythagorean identity sine squared theta plus cosine squared theta equals 1. And this is actually really important. We're going to be keep using this Pythagorean identity in pre-calc and in calc later on as well. So we have sine squared theta plus cosine squared theta equals 1. And they're telling me what sine is, so I'm going to input sine. Sine is negative square root of 2 over 5 squared. Because it's not sine, it's sine squared, so you have to square it. Plus cosine squared theta equals 1. Now, you really don't need your calculator for this. We're going to try to do it without it, but you are recommended to use or rather, it is recommended to use a calculator on your test to double check your work. First of all, if you square a negative, the negative goes away. If you do square root of 2 squared, the radical and the exponent undo each other, and you're just left with 2. And then in the denominator, 5 squared is 25. And now you're going to subtract from both sides. You're going to get cosine squared theta equals, hopefully you know what 1 minus 2 over 25 is. 1 minus 2 over 25 is the same as 25 over 25 minus 2 over 25, which is just 23 over 25. But you don't want cosine. You want cosine squared. So now we're going to take the square root. And when you take the square root, we get a plus or minus. The square root and the exponent cancel out on the left. On the right, you have plus or minus. You cannot take the square root of 23, so you leave it. But the square root of 25 is 5. So this would be our answer. We actually don't know what quadrant we're in because they didn't give us any extra additional information. So we're kind of just stuck at this answer. But they're not asking what are the values of cosine. They're just asking for a possible value. A possible value is positive, and the other possible value is negative. So just choose whichever one they give you. They're giving you the positive version. What is important is that we know how to tell which quadrant we're in. So we have quadrant 1, 2, 3, and 4. Now this is not part of the problem, but I still want you to keep this in mind. You have that sine theta is negative, and sine resembles y. So what we really have here is a negative y value if sine is negative. Now, the y's are negative in 2 quadrants. that is quadrant 3. And quadrant 4, you're going to have a negative y and a negative y. Now, they are telling you that, what did we go with cosine? In this case, let's go with the answer they gave us. They gave us a positive cosine. Well, cosine resembles x. If you're on a unit circle, cosine is x. Now, we have a positive x because the answer choice is positive. So, your x coordinates are positive on the right. You have positive x values here. So, we're really talking about this answer is in quadrant 4. Or rather, a possible answer is something in quadrant 4. Now, this did come up on the Regents one year in a very unique way. And that unique way is, they said if sine squared 32 degrees plus cosine squared of m is equal to 1, then what does m equal? Now, you should be able to recognize that this is the Pythagorean identity. And the Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Now, the thing with this is that they are both theta. So this is theta, and they are the same variable. If something is the same variable, then they are the same value. So this has to be this. They have to be the same. Sine squared of 32 plus cosine squared of 32 is equal to 1. Does not work if they are different values. And which one is always equal to 1? Cosine squared theta plus sine squared theta. This is commutative, so you can switch the order of addition. Okay, let's try now. This problem is asking you to use the Pythagorean identity, and we want to find the value of tangent. This is kind of like the do now, but it gives us something else. In this case, we're going to get to the whole 90 is less than theta is less than 180. They're telling us to use the identity. So really what you should be doing is writing the identity out. And what I suggest is that you pause the video and you actually try this on your own. They are giving you that sine is 0.8. So we're going to have 0.8 squared because it's not sine theta, it's supposed to be sine squared theta, so you have to square the 0.8. And if you do 0.8 squared in the calculator, you get 0.64. If you subtract 0.64 from both sides, you're left with cosine squared theta equals 0.36. You're going to take the square root, and when you take the square root, you get a plus or minus. So you're left with cosine theta equals, this is going to be plus or minus 0.6. Your goal is to figure out whether it is the positive or the negative. So what you're going to do, you're going to make your quadrants. Again, 1, 2, 3, and 4. And they're specifically telling you that you're between 90 and 180 degrees. These are your quadrantal angles. Quadrantal angles block off each of the quadrants. We have 0, 90, 180, 270, and 360 degrees. Now, we're going between 90 and 180, so we must be in quadrant 2. And in quadrant 2, we have negative x values, if you were to plot them, and positive y values. So that means we're going to have negative cosine, and we're going to have positive sine in that quadrant. Now, we wanted, what is cosine? I know cosine is negative. So I'm going to say cosine of theta is negative 0.6. All right, we've used the identity to the fullest. Now we can figure out what tangent is, because tangent is sine over cosine. So that gives me, what did we get for sine? Sine was in the problem. Sine was 0.8. Cosine was negative 0.6. That you use your calculator for. And your calculator is going to tell you that it's negative 1.3 repeating. So if you're to round to the nearest hundredth, that's 2 decimal places. You get negative 1.33. All right. We're going to do the next problem, but we're not going to use the Pythagorean identity for it. If you would like to, you're more than welcome to, and you'll get the right answer. But there's a very easy way to do this problem. Now, they're telling you cosine is 7 over 25. Well, if cosine is 7 over 25, cosine is adjacent over hypotenuse, right? And we want to find the value of tangent. And this only works because it's a multiple choice question. Tangent is opposite over adjacent, right? So clearly, you are going to have something over your adjacent, and the adjacent is 7. So you're going to have something over 7. What you're not going to have is the 25, because the hypotenuse is in cosine, but tangent doesn't use the hypotenuse. Tangent uses opposite and adjacent. So there will be no 25 in your answer. It's not choice 1 or 3. That means your opposite has to be 24, because that's the only other number left. But the question is whether it is a positive 24 or a negative 24. And that's where the rest of the question comes into play. You have your quadrants 1, 2, 3, and 4. They're telling us we're specifically in the 4th quadrant. The 4th quadrant is a negative, oh, no. You have a positive x, and you have a negative y. Positive because you're on the right side, negative because you're below the x-axis. Those are negative y values down below. And that's why cosine is positive 7 over 25, because in the 4th quadrant, x is positive. But we want to know about tangent. So what do you know about tangent? Tangent is opposite over adjacent. It's sine over cosine. Tangent is also y over x. Now, if tangent is y over x, we have negative y and positive x. So if you think about it, a negative divided by a positive is a negative value. We are going to keep the negative in our answer. And you didn't really have to do the question. Okay, we're going to try to get through this problem quickly. The thing is, you could choose to do the problem with triangles, or you could choose to do the problem with the Pythagorean identity. Really, either one would be fine. I'm going to do it with triangles first. So if you were to do it in a triangle, first of all, you have your quadrants 1, 2, 3, and 4. You need to figure out which quadrant you're working in. So the thing is, cosine resembles x. So the fact that you have a negative cosine, that means we're dealing with negative x values. Now, you have negative x on the left in the second quadrant, and you have negative x on the right in the third quadrant. The question is, do you have negative y or do you have positive y? And that's what we're going to use here. They're saying tangent is greater than 0. That means tangent is positive. So tangent is y over x, right? But we know that tangent is positive. I also know that my x is negative because they said cosine is negative 2/3. So I have a negative in the bottom for x. What does y have to be so that you have a positive, oh, did I just say it? Sorry. What does y have to be so that something divided by a negative is positive? You need to make this a true statement. So that means that your y value has to be negative because a negative divided by a negative is positive. So that means you have a negative y and a negative x. We are now in the third quadrant. Once you know that you're in the third quadrant, you could go and create your triangle. Your triangle is going to look like that. And on the triangle, you have your hypotenuse, you have your opposite, and you have your adjacent. The thing is that for this triangle, cosine is adjacent over hypotenuse. So your hypotenuse is going to be 3, and your adjacent is -2 because you're to the left, so that needs to be negative. Your hypotenuse is always positive. If you do the Pythagorean theorem, you get x squared plus 2 squared. You could leave out the negative, equals 3 squared. So x squared plus 4 equals 9. X squared, if you subtract 4, you get 5. And you get x is equal to plus or minus the square root of 5. That's this guy right here. Now, because you're downwards, you're going to go with negative radical 5. Now, if they're asking for the exact value of sine, sine is opposite over hypotenuse. Your opposite is negative radical 5. Your hypotenuse is 3. If they're asking you for tangent, that is opposite over adjacent. Your opposite is the square root of -5. Your adjacent is -2. The negatives would cross out. So that's your answer in the purple. But you could also do this using the Pythagorean identity if you wanted. You would have sine squared theta plus cosine squared theta equals 1. Now, you don't know what sine squared theta is, but you do know cosine. Cosine is -2/3. So you would square it equals 1. -2 squared is 4. 3 squared is 9. You're going to subtract 4 over 9 from both sides. You have sine squared theta equals, on the side, 1 minus 4 ninths is the same as 9 over 9 minus 4 ninths, which is just 5 ninths. Now, I'm going quickly because you could use your calculator to do this. And now you're taking the square root. When you take the square root, you include a plus or a minus. So we get sine squared theta equals, you cannot take the square root of 5, but you can take the square root of 9. The square root of 9 is 3. The thing is, you have to figure out if you're positive or negative, but we already determined that we are in the third quadrant where you have a negative y, and sine resembles y, so I'm going to keep my negative. So you have sine. Question also asked for tangent. So if you wanted to find tangent, now you would have to go back and say, well, tangent is sine theta over cosine theta. So for tangent, sine was negative radical 5 over 3, and cosine was, what was cosine? Cosine was in the question they gave us, negative 2/3. You could put that in the calculator to simplify. Actually, you couldn't put it in the calculator to simplify. It's not going to be nice. So here's a trick for simplifying. First of all, negative divided by a negative is positive. If you have a fraction divided by a fraction and the denominators are the same, the denominators actually cancel out and you're left with radical 5 over 2, which was the same answer that we got when we did it the way on the left. So really, if they're not telling you to do it a particular way, you can do it either way you prefer. Now, you don't have to stay to do number 13. I'm skipping around. But I do think it's an excellent question for a bonus on a test, because this is how you're going to see it next year in pre-calc and how you might end up working on it in calculus your senior year. You're going to have to eventually do a lot of manipulation, and you're going to have to realize how to simplify problems that don't look like they can be simplified in the first place. So I know this question says what's equivalent to. And yes, you could do y1 equals y1 and y2 in match graphs. But the legitimate way to use this is when simplifying problems with trig expressions, you're going to use the Pythagorean identity, that sine squared theta plus cosine squared theta equals 1. I left out my theta. Now, in this problem, we see a 1. Instead of writing 1, I'm going to write sine squared theta plus cosine theta equals 1 instead. But because they're using x, I'm going to use x instead of theta. So I have sine squared x plus cosine squared x. That's just what 1 is equal to. And I'm going to continue around with the rest of the problem. And then you're going to simplify. Now, there is a sine squared x minus sine squared x. So they subtract to be 0. And you're left with cosine squared x over cosine squared x. So something divided by itself is just 1. So this expression is equivalent to 1. And that's all.